This will be the first of two videos in which we look at how to graph parabolas in vertex form. In this one, I'm going to be looking more at how to graph just using a typical table of values and plugging in numbers. And then in the next video, we'll see how to do so a little bit more quickly using some shortcuts. So this lesson is all about graphing in vertex form. Part 1. Quick refresher on what you would have seen in your last lesson or your last video. Our vertex form is y equals a times x minus p squared plus q. And those three letters, A, P, and Q, all do different things. So A controls the direction, so whether the parabola opens upwards or downwards, and the width. So when A is large, the parabola is skinny and goes up quickly. When A is small, it is wide and goes up very slowly. Positive A's make the graph open upwards, and negative A's make it open down. P translates the graph left or right, so horizontally. And translate just means moves it side to side without affecting the shape. Q does the same thing, except it moves it vertically. So up and down. And so positive p values move the graph right, negative p values move the graph left, and positive q values move up while negative ones move down. One of the most important takeaways is that our vertex is also based off of those last two numbers. So our vertex is going to be at PQ. And that's going to be really important for us when we're drawing our graphs. So if, for example, we wanted to graph the function y equals x minus 2 squared minus 3. It's a pretty simple one. It's a good place to start. So our first step, no matter how we're graphing, the first thing we're going to want to do is to figure out where the vertex is. Because since it's the middle of the parabola, it's an easy place to start. In this case, remember we want to look at our P and Q values. So it's easy to get mixed up here. Q is negative 3. That part's pretty easy. But P is not what it looks like. P is not negative 2 here. It's actually positive 2. Because our basic vertex form is x minus P. So if you're going to end up with x minus 2, that's x minus positive 2. Versus if you have x plus 2, that's going to be x minus negative 2. So you've got to be really, really careful, and it's a really common mistake when people are first learning about vertex form. Once you've got your vertex, step 2 is going to be to just make a table of values. Just your standard T-chart. And we can be a little bit more specific there, because when we make that table of values, we're going to want to make the vertex be in the middle, because it's the middle of the parabola. So we're going to set up our table. Just your usual X and Y. And if you watched my last video, you might remember that I said that we typically want about 5 points for our parabolas. 1 is obviously too much. 3 is lacking in detail, but is okay. Sometimes 5 is a nice standard. So for us, we're going to put that 2, negative 3 right there in the middle. Then we just want some x values on either side of the vertex. You don't want to go way too far off. So if 2 is our middle, Well, if we want to the left of the vertex, we'd probably use x as 1 and 0, and then to the right of the vertex, 3 and 4, which gives us a nice set of 5 points. And maybe we should write that down. So use x values on either side of the vertex. All right, so now we're just going to take those x values and we're going to plug them in one at a time into our function. So that's step 3. Plug in the x values and calculate. So for us, remember our function is y equals x minus 2 squared minus 3. So if we take x equals 3 and plug it into our function here, we've got y equals 3 minus 2 squared minus 3. And then we just have to follow our order of operations and be careful to make sure we're calculating our negatives properly. So 3 minus 2 is 1. 1 squared is also 1. And then 1 minus 3 gets us negative 2. We'll do the same thing for x equals 4. So we've got y equals 4 minus 2 squared now. Minus 3. 4 minus 2 is 2. 2 squared is 4. And 4 minus 3 gets us 1. And so we go back up to our table of values now. And so when x is 3, y is negative 2. And when x is 4, y is 1. And so we can fill those 2 points in. But here's the nice thing about parabolas. We can actually stop here and we don't have to calculate those last 2 points. And the reason for that is because, if you remember, our parabolas have symmetry. So they are mirrored on either side of the vertex. So this point, which is 1 to the right of the vertex, will be the same as this point, which is 1 to the left. So this will also have a y value of negative 2. When x is 4, which is 2 to the right of the vertex, that's going to have the same y value as when x is 0, because that's 2 to the left of the vertex. And this is why it's so helpful for us to put the vertex in the middle. So remember, use symmetry to get more points. So even though we want 5 points on our parabola, we only actually have to find really 2. Because the vertex you'll be able to figure out, and then we're calculating 2 points, which will end up getting us 4 more points. And now that we've done that, we can move on to our last step, which is just graphing. We're going to take those points, plot them on a graph, and see how it looks. So for most graphs, you're going to want to look at the numbers that you've made in your table and how far they go and how big they are before you decide what your axes are going to look like. In this case, because our biggest numbers are really only 4, we're going to make a 5 by 5 grid. So 5 up, 5 down, 5 left, and 5 right. Remember, once again, that you want to have arrows on your axes. You want to have labels on those axes as well. And then we just want to write down our scale. Okay. And so if we take our points and start plotting them, we had we had 0 and 1. We had 1 and negative 2. we had 2, -3, 3, -2, and 4, 1. Those are our 5 points. And that gets us our parabola. So now you're going to want to draw your curve. Remember, you don't want it to have any weird straight lines. It's never going to be vertical. So do your best. Try to go a little bit beyond the points that you graphed, because the parabola does keep going forever, and it makes it look better. So usually I try to go to the edge of the axes that I've drawn. Something like this. And there we go. We have our first parabola. So let's try another one. So we want to graph y equals 2 times x plus 3 squared minus 5. Our process is going to be the same. So we want to look and see where our vertex is. In this case, our vertex is at, well, P and Q. So Q is -5. What's P is the question. Is it +3 or is it -3? So the key to remember is it is the opposite of what it looks like. This is not x plus 3. This is x minus -3. So our vertex is at -3, -5. So then we're going to go to our table of values. We're going to put that vertex in the middle, so -3, -5. And then, once again, I just want 2 points on either side. So -4, -5, -2, and -1 are probably our best bet. You don't have to show all of your calculations as you do this, so some of it can be mental math. I'm going to show one calculation just to kind of lay the groundwork. So if I take that -1 value that we've got in our table for our x's, and I plug that in, we've got 2 times -1 plus 3 squared minus 5. And again, you've really got to be careful with your order of operations here. So we want to do the brackets first. So that's -1 plus 3 gets me 2 squared minus 5. 2 squared is our next step. So that's 2 and then times 4 minus 5. 2 times 4 is 8. And then 8 minus 5 gets us 3. So when x is -1, y is 3. But through the power of symmetry, that also means that when x is -5, y is going to be 3. If you go through and you plug -2 in here, -2 plus 3 is going to be 1. 1 squared is also going to be 1. Then that times 2 is going to be 2. And then 2 minus 5 is going to get us -3. So these 2 points are going to have the y value -3. And that gets us everything we need. We have our 5 points. So we're going to get ourselves another grid. So you might want to pause the video here because I'm just going to bring one in out of nowhere. And once you've got your grid all drawn up, you plot your 5 points. So we have when x is -5, y is 3. When x is -4, y is -3. Then we have -3, -5, -2, -3, and -1, +3. And there's our parabola. So you might notice, if you're looking at this, that it seems a little bit skinnier than the last one. And that's because we have an a value of 2 this time instead of the a value of 1 we had on the first one. So we come down and we do our best. I find it tends to be a little bit more difficult to draw nice parabolas the bigger the a value gets. That's just me. I'm not very good at drawing anyways. So there's an okay attempt at a parabola. You notice it's a little bit wonky on the right side, but it's okay. And there we go. That's this question done. So I'm going to give you a couple of more examples that you can do on your own. If you're feeling comfortable, feel free to just burn through them. I won't give too much of an explanation on these ones. So for this next one, you want to try graphing y equals negative times x minus 2 squared. So feel free to pause here, work through this question, and then come back to check your graph once you're done. So looking at this one, you might notice a couple of things. First off, there's no Q value. So for our vertex, we're actually going to have a Q value of 0. Our P value is 2. So that's our vertex, 2, 0 right there. And you know what? I'm just going to go ahead and throw that on the graph right now because I know where that point is. Our A value is -1. So there's no number in front of the brackets, but we do have that negative. So our A value is -1. And thinking back to when we were learning the characteristics of parabolas, that means our parabola is actually going to be pointing downwards. So right off the get-go, I know it's going to look something like this, but we want it to look a little bit nicer than that. So we make our table with the same process. We put the vertex in the middle. So x is going to be 2, y is going to be 0. Then we'll use x is 1, x is 0, 3, and 4. If you haven't already, go ahead and take those x values, plug them in. This one's pretty easy to do in your head because there's no q value. So when we put 0 in there, 0 minus 2 is -2. -2 squared is +4. But we've got a negative out front, so this ends up as -4. And that's going to be the same down here. And when you put 1 or 3 in there, you should end up with -1. So we go ahead, we plot those points, and we get a parabola that looks like this. From there, go ahead and draw your curve, doing your best, again, to be as smooth as possible, to hit all of your points, and to not have any weird straight lines. And there you go. Very nice, very clean, and a little bit simpler than some of the other ones. For our last one, I'm going to give you something a little bit trickier. So I'll get you to graph the following. Y equals -1/2 x squared plus 3. So again, feel free to pause here, work through your table of values, draw your graph, and then come back once you're done. All right, so our vertex on this one, once again, this one looks a little bit weird, but you'll notice there's no brackets. So normally it's x minus p inside the brackets, but if there's nothing being subtracted with the x, with that square, that actually means p is 0. So comparing the last one, where q was 0, so we had nothing outside the brackets, here p is 0 because we have nothing inside the brackets because the brackets aren't even there. So our vertex on this one is going to be 0, 3. If I get my grid up, that means our graph starts up here. I know it's going to be opening downwards because my a value is negative. That fraction out front is going to make this a little bit trickier. We know because the a value is small, the graph is probably going to be a little bit wider, but we are going to have to deal with some fractions. So I'll go ahead and work through plugging one of those in just to kind of walk through the process. So if x is 1, I'm going to have 1 squared. So it's -1/2, well, times 1 plus 3. 1/2 times 1 is just 1/2. And then -1/2 plus 3. You can turn this into a decimal if you want. You can hop off to the side and do your fractions if you want. If you can do it in your head, feel free to do it in your head. But one way or another, you should end up with either 2.5 or 5/2. So when x is 1, our y value is 2.5 or 5/2. So we get points there and there. If you do the same thing with 2, I'm not going to show you the process, but when x is 2, y is going to end up being 1. So you're going to end up with points there and there. And so once again, it's a little bit skinnier of a parabola. You might want to do one more point, maybe plug in x is 3 and -3. It's not mandatory. It'll get you a slightly better image of what your parabola is supposed to end up looking like. But this ends up being okay. And so we get our parabola that looks like this. So this is a really valuable skill. That's something we're going to do a lot of in Pre-Calc 11. So take your time, practice this as much as you feel like you need to, do some extra practice problems out of the textbook, and then once you're ready, go ahead and move on to the next video where we're going to learn how to graph without doing all of these calculations. We're going to see how to go straight from an equation or a function like this to a finished graph.